You tell me if there's any questions. Isosceles triangle. Both of my base angles are 52. The altitude that comes down bisects this in half. Okay, so use you're looking for this guy in here, so use your tangent function. Make sure when you put tangent of an angle in that your mode is degrees. Stop me if you have any questions. Yes? 3 decimal places. Usually we go 3 decimal places. That's just our rule of thumb for pre-calc. That's the suggested rounding that calculus people tell us to do. 3 decimal places. Because as you get more exact in this, you have to round a little further. That's why when we do the trig functions, they're exact values. Okay. This, simply drop your right triangle down, make a right triangle. Remember your angle of depression? Because this is a perpendicular line, these 2 lines are parallel, so these are your alternate interior angles. And the same would go, these are supplementary, these are complementary over here for your right angle. So the complement of that is the complement of this guy, which is that. So easy way around it. Questions? Yes?
When are we having a test?
Well, I'll address that in a second. Questions on this? Right?
I just rounded to the nearest decimal point.
Unless it tells you, we go 3 decimals.
Okay.
Sometimes the problem will say around to the tens, hundredths, but unless it does, 3 decimals.
Okay.
A rule of thumb, 3 decimals.
Do I have to drop it right there, or could I just continue to
No, you don't have to. No, I just drew it in case somebody doesn't see the triangle. And I know mine doesn't exactly look like a right triangle, but use your imagination. They didn't make me pass art to become a math teacher. They should. Okay, an A-frame. And if you didn't know what it looked like kind of draw the A. It says we get an isosceles triangle. It stands 28 feet high. The H is your altitude. And it is 20 feet wide at the base, so it cuts it in half again. Now you're looking for this angle. Okay, so to find an angle, inverse function. Yeah.
Question, because like it says find the angle relation of its roof, not the to it, so it's all like really confused on what that meant.
So yeah, so of its this would be the frame of your house, right? Wherever, here. And this would be your roof. So the angle of elevation from the top of your house to the roof. I'm thinking that's what they mean, right?
Oh, yeah, because I was wondering about it. I did it inside, but I didn't.
Because your roof is at the top of your house. So you make your frame first, and then your angle of elevation, that's how they measure the pitch of your roof, by the angle of elevation.
Okay.
Yeah. Okay. Make sure you round again, and make sure your mode is degrees. Okay, here's a nice little one. Again, you're looking for the height of this drop. Angle of elevation is here, this little tiny piece in here. And you're looking for the drop. The slope of that hill is what we're looking at here.
Can you go back to the drawing?
This one?
Okay.
Can everybody find an angle given the sides on their calc? Second hand. These are not your special triangles. So make sure your mode is degrees. If I want the angle, then I want the inverse, second hand. That's that inverse symbol. And don't reduce it. Just put it in just like that. Let your calculator worry about it. And it gives you your angle. And again, go to, unless it says to the nearest angle, everything is 3 decimal places. Okay with this? This one is kind of like the one we did in class. Drop 2 triangles here. Here's one. Here's the other one. drop your two triangles. Okay, it shares this height. Now I want the difference over here. So I'm going to do the large triangle and the small triangle and subtract them. No law of signs necessary. We have two right triangles. We don't have to find the side in common and figure out anybody else. And these guys are angles of depression. So this has to be the 4. This has to be the 6.5. A little higher. Whoops, wrong. This is the 6.5. This is the 4. So we went out a little further. This goes to this line. So take the tangent of both and then subtract them. So you're rounding at the end. Yeah.
Okay, but,
Oh,
yes.
yeah. This board loves me.
You know, on the picture, like, it asked, like, how far away the post are, so it was really close. I was really, like...
Well, don't forget, everything is not drawn to scale. Not drawn to scale. And that's why some of these pictures I don't like, because they're not drawn to scale. Sometimes they make this one very, very different than down here. You would think this distance is almost the same as that distance because it's almost the same size, but it's not. So they're so not drawn to scale. And you could tell this distance over here, God bless you, is far more than that distance over there. You can't go by the drawing. The drawing is just a sketch for you to put it in perspective, but it's never drawn to scale. That's the other one with that spaceship one. It was so not drawn to scale that it was not easy to look at. I think that was the last one, right? Questions on this one? Yes.
Isn't there another way to find the distance without having the right triangle? Isn't it law of sines, law of cosines?
There is the law of sines, law of cosines. You'd have to find this piece here. You'd have to find this piece. And then you'd probably have to find this hypotenuse. And then you could do your law of cosines or law of sines. Then you have both pieces to do. But don't use law of sines. We don't use it. We just, right triangle trade makes life a little easier. We don't do it. And I don't even know why we bothered to do this, but it's more like a review than anything else, because really, we don't go anywhere with this either. All right, let's hit the other one. I'm more concerned with this one, that you can do this. Okay, again, you don't have to work off of a unit circle. You can use any radius, but you have to be able to identify when you have a unit circle and when you don't. So here's a point on my circle. Again, here's the circle coming around. There's the terminal side. This is a point on my circle, the X point, the Y point. So as soon as you put this in, you should recognize this to be your special right triangle. You need to be able to identify those special right triangles. Okay, here's another one. This is also a special right triangle. The X and the Y are exactly the same. So that gives me what angle? 45. And remember, we said these could be where they're multiples of each other. They don't have to be the one you memorized.
So when we find R, we want to use it, right?
Well, here's the thing. When you do the sign of this, you say y over r. You have to reduce this fraction. So what I was telling you the other day is you might want to go in here. Each of these has a multiple of 2 that I could reduce this by. So if I divide this by 2, if I divide this by 2, if I divide this by 2, and then I use this, I don't have to reduce it anymore. They're all reduced before I start. But otherwise, each one of these, I'm going to have to reduce. You cannot leave these unreduced in the fraction or the radical. They're always lowest exact form. That was one thing that Algebra 2 stressed all the time. Put it in lowest fraction, lowest radical. It's automatically a given that you're going to do that. So my advice is take what's in the box and reduce that if you can. It saves you a lot of reducing. And in quadrant 2, don't forget your x is negative, your y is positive, your r is always positive. Stop me whatever you're not getting because this is important. There's a whole bunch of different things on this worksheet, which I like. Okay. How do I know this is not my unit circle? Because what? The x and y's are greater than 1. The radius would have to be 1 on my unit circle, which has to be the largest size. All the other ones have to be smaller than 1. But they're not. So I know this is not my unit circle. That's okay. This is still my x and my y. And you just have to use Pythagorean's theorem to find it. And this is called one of your Pythagorean triples. It just works out to be all integers. Do you have to memorize those? No, you'll find them as soon as you do Pythagorean's theorem. That's another triple over there. Okay, this guy, this is what's nice about this. We locate what quadrant this is. This is quadrant 4. So your angle went here and terminated here. At that point. That's the x and that's the y. And find your r. Can we do these? Okay, not everything is a special triangle. Only the special ones are you going to find your angles for. If I need the angle here, I'm going to have to use the inverse. Okay, these? Everybody okay with these? So sine, and this is how you tell yourself, sine is your y. My y is negative down here. So this part is my negative sign. My cosine is my x. My cosine, my x value is negative here. This one, this one. So where did they overlap? Right here.
I was doing it as positive, that's why.
Oh, positive, yeah. Less than 0, think of your number line. Less than 0 tells me negative. Greater than 0 tells me positive. And you can always test this. You can always do this. Pick an angle in quadrant. So I know it's everything but quadrant 1. Pick an angle in quadrant 2. So say 120. So just say the cosine of 120 is negative. Oops, I put in sine. The sine is positive, which I want the sine to be negative. So could I possibly be in quadrant 2? No. Pick an angle in quadrant 3. Just go past 180. 190. Sine of 190. It's negative. Cosine of 190. It's negative. So there's where my angle is. You can just pick angles as well. Okay. Cotangent is the same as your tangent. And cosine has to be positive where the x is positive. Tangent is positive always in the first one. Everybody's positive in the first. And tangent is positive in the opposite. So tangent is positive here and here, negative here and here. So wherever they overlap. For this to be positive, say it the other way. Cosine has to be positive, sine has to be positive, or cosine has to be negative. God bless you. Sine has to be negative. So since this cosine is positive, it's got to be this condition. It's got to be quadrant 1. Good? Okay. Again, I don't know if I have a unit circle. I don't know what this is. I can tell right by my denominator, because this is my r, not a unit circle. And that's okay. All I need to do is find the other functions. I set up my triangle, and they've told us this angle lies in quadrant 2. What other quadrant could this angle lie in? One, right? Where's sine positive? Sine is only positive in 1 or 2, wherever the y is positive. That's why use the axis behind this angle to help you, behind your triangle. So they have to tell us where it is because it obviously affects these guys. Stop me if you have any questions, guys. This is really, really important that you get these. Okay, this one, they told us the tangent is negative. The tangent could be negative here or here, where the signs are opposites. Cosines and sines are opposite. But I need my sine to be negative. Is my sine negative up in quadrant 2? No, my y is positive, so it's got to be in quadrant 4. Everybody put this in quadrant 4? Okay. Find your pieces, and you should get the rest. Okay, secant, if you'd rather work with its reciprocal, secant is the reciprocal of which function? Cosine. So if you take the reciprocal of this one, you flip it upside down, you flip this one upside down. And work off the cosine. And it has to be somewhere between 0 and 180. And where is cosine negative between 0 and 180? Second quadrant. There you go. It can't be in quadrant 3, even though cosine is negative. So they have a number of ways of pinpointing where your triangle has to be. Again, this is your special triangle. If they ask for an angle, you should be able to find this angle. So if they asked for this angle that started here and terminated here, what angle is it? The radians.
Oh. That's 133.
Radians. Give me radians.
5 or 6.
Can't be over 6. Why can't it be over 6? Well, who is opposite the radical 3? 60. Come on, think. How many times does 60 go into 180? 2 pi over 3. You know these angles. If this is a 60-degree reference angle, it's got to be over 3. So this is 3 pi over 3. This is 6 pi over 3. So this guy right here that terminates has to be 2 pi over 3. The special angles you can do. The other ones with the 5s and the 18s, you can't do those. This one's a little tricky too. Cotangent is undefined. What does undefined mean?
The denominator is 0.
Good. That means my denominator is 0. And cotangent is which values? X over y. So tangent is y over x. But my cotangent is undefined. If I want to, I can flip this over. So I've got a point here that looks like this. My x is 1, my y is 0. Could my x be negative 1? Is it still give me an undefined cotangent? So I have two possibilities. So on my unit circle, it's either going to be here or it's going to be here. So what do they tell me? What do they restrict this to? Good. Between 90 and 270. So where does it have to be? 180. Pi. It's a tougher one. Undefined means they divide by 0.
You don't have to, so if it's on the line, you don't have to say a quadrant. You have to wait.
It's not, it's called a quadrantal angle. It's a quadrant angle. It's on a quadrant line. It's on the grid. You actually, when you do this is why one of the reasons too we work off your unit circle, because it helps you with these guys. Technically it's this. They don't technically make a triangle because your x value is 1, your y value, it didn't move, is 0, and your radius is 1. So the sine of 0 is y over r. 0 over 1. 0. the cosine of 0 is x over r, 1 over 1, 1. You still can do this as if you were doing a triangle, because what happens is these two will be the same. Two of them will be the same as the radius. Something has to be the same as the radius. It's like a collapsed triangle. But you can still absolutely do all of these. Yes.
Wait, so how do we label the quadratic angle for that side?
Say that again?
You said you call it a
Quadrantal.
Yeah, so how do you label between each one?
How do you label it? This is your 0. This is your pi over 2. This is your pi. This is your 3 pi over 2. And this is your 2 pi back to here.
Okay, you see your pi.
Yeah. How many degrees in this? 90. So every 90 degrees. So 90 is half of 180, right? So pi over 2 is 90. So count. 1 pi over 2, 2 pi over 2, gives you pi. 3 pi over 2, 4 pi over 2. Now, this brings me back to some of you when you did that chart, your 0 should have been the same as your 360, and it wasn't. 0 and 360 are the exact same point. They just met back up there. So sometimes these get a little bit tricky. Okay, find these exact values. Now I won't ask you exact values unless they're quadrant angles or special right triangles. So locate where this point is. It's past the 180. How far past the 180? I subtract these, 45. There's my reference angle. Good. So I have a 45-degree triangle. I label my parts whichever way you like. Do the one that you like the best. 1, 1, radical 2. Remember in quadrant 3, the x is negative, the y is negative. And you should be able to find all your pieces. These are exact values. You cannot pick up your calculator and give me that value. That's an irrational number. Except for the tangent. Where do I find negative 750? Good question. Good. 2 revolutions. This is 360. Another 360 gives me 720. And Anthony said another 30 degrees. There's my 30-degree angle in quadrant 4. Yes?
Couldn't you just like subtract 720 from it? Just use 30?
Yep, and use 30. However, what quadrant are you in? Fourth. You have to be in the fourth. It's negative. It's your 30-degree triangle, but you have to place it in the fourth quadrant. Absolutely. And you should be able to get those. 5 pi over 3. Again, here's your reference angle. 180 divided by 3, 60. This is my 3 pi, my 6 pi. So I go this way, I'm 1 short. Remember, it's 1 up and down. There's my bow tie. Negative pi over 6. A negative forces me to go clockwise. It sounds like it would be the opposite. And a lot of kids get confused with that because they like to work clockwise, but we rotate counterclockwise. So a negative forces me clockwise. 6 goes into 180 30 times. Same as 5 pi over 6. Exactly. No. Same as 11 pi over 6. Same as 11 pi over 6. So, what do we call those? Coterminal angles. Good. This one was a little bit strange. 11 pi over 4. So when I do my 4s, this is 4 pi over 4. This is 8 pi over 4. But I'm circling again, so I add another 4, and I get 12 pi over 4. So who comes before 12 pi? 11 pi over 4. That's why if you get the pattern of the radians, it's so much easier. There's a 45-degree angle. And the same thing with this guy. There's a 30-degree angle. 6, there's 12. If I add another 6, I'm at 18. And, oh, this went negative, so I've got to start here. and I'm a little bit short of my 18. There's my 17. Can everybody do these? Know these right triangles now? Any questions? This was it, right? That was it.
Oh, question. Is it, for 77, is degree that you said is 30, is it 60 or is it,
Well, how many times does 6 go into 180?
30?
30. 30-degree reference angle. You go by this denominator. It went the opposite way. It went negative. So I have to start like this. I go all the way around and come back. So how do I know that if I do 6s? This is my 0. This is my 6 pi. This is my 12. I got to go another before I do this. Oh, it's 12 pi over 6. So this is going to be my 18 pi over 6. So if I start here and go around to 12, this brings me to 18, one short, 17. The radians work real well with patterns. Good. All right.
But